Yesterday we were discussing about laws of reflection, how to get parallel rays, and then we were discussing about convex and concave mirror. Today we will discuss more about convex and concave mirror. What is this convex and concave mirror? They are curved mirrors. Let us take the help of your hand to understand this. Suppose this is a surface, curved surface. If you have mirror here and it is coated backside, this is called a convex mirror. If a mirror is here and it is coated behind, then it is called a concave mirror. Now, if the coating is over here and this is the reflecting surface, then this is called convex mirror. If the coating is over here and this is the reflecting surface, then it is called concave mirror. You can take the tablespoon. Let us say this is the tablespoon. This part, the inside part, this can be treated as a concave mirror, and the back side, behind part, this can be treated as a convex mirror. Now, in today's class, we will be discussing certain rules on how the light rays get reflected on a concave mirror and a convex mirror. Let us look into it. Before going to this, we'll learn some terminology for convex and concave mirror. We'll learn some technical terms. First one is pole. Second one is principal axis. Third one is radius of curvature. Fourth one is center of curvature. Fifth one is focus. The sixth one is focal length. Okay, let us look into these terms today. First one is pole. It is denoted with capital letter P. Radius of curvature is denoted with capital letter R. Center of curvature is denoted with C. Focal length is denoted by small f. Point of focus is denoted with capital F. Okay. Now, let us start with a concave mirror. Now, if this is a concave mirror, the midpoint or the central point on the mirror, this is called pole. What is it called? Pole, and it is denoted by the capital letter P. Next, suppose if this is a part of a sphere, then this sphere will have some center. That point is called center of curvature and it is denoted with C. Now, so you know what is pole and what is center of curvature. I repeat again, if this is a part of a sphere, then that sphere will have some center. That is called center of curvature and it is denoted with C. Now, the line passing through pole and the center of curvature, this line is called principal axis. What is it called? Principal axis. And the distance between P and C, this is called radius of curvature. What is it called? Radius of curvature, and it is denoted with capital R. Let us look into the definitions once again. If this is a concave mirror, the central point or the midpoint of the concave mirror is called pole. If this is a part of a sphere, the sphere will be having some center. That is called center of curvature. Now, the distance between pole and center of curvature, this distance is called radius of curvature. And yes, so we have covered how many definitions? We have covered about 3 definitions. One more is the line passing through pole and center of curvature, that line is called principal axis. So here we have covered pole, principal axis, center of curvature, radius of curvature. Let us discuss about focus and focal length. Now, take this concave mirror in the sun. What kind of rays will fall on this concave mirror? Yesterday we discussed about candle activity, where I told you that whenever you are keeping the candle closer to this thermocol cube on which we fix 2 pins, you will get diverged. You will see that the pins are in the shadow, the pins are diverged. But as you take this candle away, you will get parallel rays. So, in order to create parallel rays, you need to take the light source, you need to keep the light source far away. Now, you want a parallel rays to fall on this concave mirror. So, what I can do is, I can take this concave mirror under sun to get parallel rays. Now, let us say I am taking this to sun. So, what kind of rays will fall on the concave mirror? Parallel rays will fall on the concave mirror. Now, as they fall, they all get reflected. You will see that they all meet at a point. This point is called point of focus. This point is called what? Point of focus. Now, what you do is you take a paper as a screen and move it in front of this mirror. Keep it at a place where you get a sharp image, a clear bright spot. So, when you keep it at point of focus, you will get the clear bright spot, which is nothing but it is the image of the sun. Now, if you move that paper in the front, you will see that the spot becomes smaller and smaller. At the same time, if you move the paper back behind focus, you will see that you will get an enlarged image of the sun. So, at focus, you will get a clear bright spot, which is the image of the sun. So, this point is called point of focus. It lies between P and C. That is, it lies between pole and center of curvature. The distance between the P and F or F and C, this distance is called focal length. It is called what? Focal length. You will observe that radius of curvature is twice the focal length. So, now you understood what is focal length? This point is called point of focus, where all the reflected rays meet. If you are keeping a paper here, you will get a clear bright spot, that is the image of the sun. If you are taking the paper towards P, you will get a smaller image. If you are taking up the paper away from focus, you will get a enlarged image. Exactly, you will get a clear bright image at point of focus. Now, the distance between P and F, this distance is called focal length. What is it called? Focal length. It is denoted by small f. You will observe that the focal length is twice the radius is twice the focal length, radius of curvature, P and C. This is radius of curvature. You will observe that this distance is twice the focal length. It is either the distance between P and F or F and C.